So in the last video, we have learned about the detailed process of hypothesis testing and about the inferential statistics. So this is the last video from my end about the statistical analysis for research. In next video, Dr. Priyanshu Rathod will going to teach you that how you can perform all this kind of descriptive statistics or inferential statistics or hypothesis testing with the help of statistical software. So before I start, I recall one of the very popular again joke about like inferential statistic, which has been portrayed in form of the cartoon. Like here you can see that a boss and employees talking with each other. A boss is to say that our big data analysis tells us that only the top performers leave for the higher pay. So that is the like outcome of the hypothesis testing. And then probably he made the inference that since you are still here, it means your performance is average at the best. And definitely the reaction from the employees, that's not fair. So again, boss again reply him that that's what all the average people say. So this always happens with the statistical test and hypothesis testing, that substantively we find that okay, it is not worth to reject the null hypothesis, but since because on the data which we have collected and test we have applied, it again shows us that we need to reject the hypothesis. So sometimes you may be in the situation like this, but nevertheless we need to keep on doing the good analysis for the research. So in this video, I'm going to just give you a glance of some of the other useful statistical approaches which you can use for your analysis of this research work. So let us first start with the regression analysis. So regression analysis is basically a process of constructing a mathematical model or a function that can be used to predict or determine one variable with the help of another variable. So if we take an example of simple regression, then there are two variables in simple regression. One will be called a dependent variable and second is called independent variable. And we are in a simple regression, we try to develop a mathematical model where with the help of the values of independent variable, we try to predict the value of dependent variable. So generally dependent variable is the variable that has to be predicted and it used to get denoted by y. Independent variable, which also used to call as predictor or explanatory variable, is generally denoted by x. And generally the simple regression equation looks like y cap, that means predicted value of y, that means dependent variable, is equals to b0, which is a sample intercept or constant, plus b1 into x, where x is an independent variable and b1 is a sample slope of x or coefficient of x, right? Let's take an example that we want to say that sales, we can able to predict the value of sales on the basis of independent variable, how much money we have spent on advertisements. So here x, that means money spent on advertisement, can be an independent variable. On the basis of that, we try to predict the sales. So here there is one independent variable and one dependent variable, so that will be called simple regression model. If I also said that sales doesn't only depend on advertisement, but it also depends on other independent variables, that how much discount a company or a brand are offering, or where is the location of the store, what is the skill set of the sales employee. That means when I'm trying to consider more than one independent variable in my mathematical equation of regression analysis, I am using a multiple regression model. Means y cap, that means sales is the value which I want to predict, so that will be dependent variable and remain the same, but I am taking into consideration more than one independent variable. That means x1 equals to advertisements, that means money spent on advertisement, x2 equals to percentage of discount offered on a brand, x3 equals to location of the store, and so on. So when there are more than one independent variable and one dependent variable, the equation which you used to develop is called multiple regression. So friends, most important thing which we need to learn here is how to analyze the output and make the interpretation of the output which generated from the computer software or Excel. So let's have a look at that. So this is one of the output of multiple regression. Here we have two independent variables. One is temperature and second is humidity. And we try to establish a relationship that yield is largely dependent on temperature and humidity. So these are x1 and x2, and this can be termed as a y. And when we performed the regression analysis with the help of Excel, we will get a similar kind of an output. So here the first and most valuable regression statistic which we need to learn is R square. So the value of R square, which is called coefficient of determination, is 0.98. That means this model, the regression model which we have developed, is fit for the, or it is a good model to predict the dependent variable. See, like again here what we have developed, that yield is equals to 5.14 minus 5.14, this which is the intercept, plus 2.19 temperature, that means the first x1, plus 0.15 into humidity, which is the second independent variable, x2. So this is the regression equation which has been developed with the help of statistical software. Here there are two independent variables. This is a regression statistic which is R square, which is called coefficient of determination. Here the value of R square is greater than 0.07. That means the model which we have developed to predict the yield is a good model and fit for regression analysis. Further, if you want to see that out of these two models which we have developed, temperature and humidity, which is a good predictor and which is an average or below average predictor, then we need to look at the p-values of individual predictors. So here the p-value of temperature is less than 0.05. That means we can say that temperature is an important factor for predicting yield. But the value of humidity is 0.44, which is greater than 0.05, which means humidity is not impacting yield significantly. So you can also eliminate humidity from this developed regression equation, and it may be possible that it may increase your R square or reduce your standard error. So this is a coefficient which represents that with 1 unit of increase in temperature, there is almost 2.19 times increase in the yield. So whenever one unit of temperature get increased, it will going to increase the yield by almost 2.19 times. So this can be represented in coefficient of an independent variable. Let's look at one more analysis so that you can get more clarity. And this is another output of regression analysis. Here the price used to be a dependent variable, and there are two independent variables which we have taken into consideration. One is color and second is quality. And we want to see that whether the model which we have developed, that means price is a dependent variable, and we can predict the value of price based on what is the input value of quality and color of the product. So here if we look at the multiple regression, multiple R score, it is 9.92. That means 92.23% of the variability we can able to explain from these two variables only, right? So it is a very good, significantly very good, and the model which we have developed to predict the price is a good model and fit for regression analysis. Same way, we can also analyze the ANOVA table which has been generated in a regression analysis. Here you can see the value of the p-value is less than 0.05. So again, it rejects the null hypothesis that model is not fit for regression analysis. Here we can say that model is good predictor and model is fit for regression analysis. Similarly, out of these two independent variable, if you want to see that which is a good predictor and which is not a good predictor, we can look at the p-values. Here, both the p-values, that means 0.0003 and 0.001, both are less than 0.05. So we can say that color and quality both are a significant and good or predictor which is impacting the value of the price. So this is another example which we discuss about how we can interpret the output of multiple regression. Friends, other useful techniques which you may adopt for your analysis is logistic regression. You can use logistic regression when one of the dependent variable in your regression equation is dichotomous, that means binary in nature. Whereas the independent variable can be any type, like it can be a nominal, ordinal, integral, ratio, but specially the dependent variable should be binary in nature. Similarly, you can also apply a discriminant analysis. You can use this technique when the criterion of the dependent variable is categorical in nature. right? Whereas the predictor or independent variable can be interval or ratio in nature. For example, if we want to predict that on the basis of certain independent variable, if you want to predict that which brand a customer is going to purchase, so brand, whether he or she will going to purchase brand A, brand B, brand C, brand D, which are a categorical in nature. So we want to predict that which brand he or she or consumer is going to purchase. So here the dependent variable is categorical data. So in that case, we can use discriminant analysis. Another very important statistical tools which you can use is factor analysis. There are two types of factor analysis. One is called exploratory factor analysis. Second is confirmatory factor analysis. You can use exploratory factor analysis in situations where you want to reduce a large number of variables into few number of factors, right? This works on the basis or technique called extraction of maximum common variance from all the variables and put them into a common score. For example, when I plan to purchase a car, almost I have made a list of 27 different factors which influence my decision. But again, to reduce this 27 number of factors into few meaningful factors like 4 or 5 factors on the basis of commonality, I can reduce that with the help of factor analysis. Similarly, there is a confirmatory factor analysis which can be used to determine factor and factor loading of measured variables. So if there is already a pre-established any structure equation modeling or any model which has been already developed, and if you just want to confirm that whether your research data which you have collected conforms to pre-established theory, then you may go ahead with the confirmatory factor analysis. So confirmatory factor analysis confirms what is expected on the basis of pre-established theory, right? So generally it assumes that each factor is associated with specific subset of the measured variable, right? And accordingly it works and confirms the pre-established theory. If you are in the field of marketing, then one more technique which will be very useful to you, which is called cluster analysis. Generally, it is a class of techniques that used to classify object or cases into a relative group called clusters, right? And cluster analysis will be very useful for the in the area of marketing, especially if you want to identify different segment of consumers on the basis of, and if you want to form a identify homogeneous group of buyers. So this is yet another method which you can able to use to classify a group of customers with a homogeneous kind of a characteristic, or if you want to segment a different class of customers. So there are many more tools like structure equation modeling. There is a ANOVA, repeated ANOVA, multiple ANOVA. So you can explore that when you have a hands-on on some of the statistical software. Because of limitation of time, I can only able to give you a glimpse of this kind of advanced statistical technique which you can use for your analysis. Last, I want to conclude with this particular quote. Like, I always find that I did a statistical analysis and found no correlation between my efforts and my rewards. Many times, whenever you are doing a research for your PhD, you also try to going to have a similar kind of feeling during the journey of the PhD. But I want to assure you, if you work hard, then definitely you will find there will be a correlation between whatever efforts you are putting and whatever rewards you are getting. With that, I wish you all a very best of luck for your coursework and further subsequent journey of PhD. Still, if you have any query, then you can drop me an email on my email ID chintan.rajan@rk.se.in, and looking forward to meet you all personally and to have a hands-on session some days down the line. Thank you very much.